These slides are going to deal with levels of measurement. So the first deal with levels of measurement, we're really referring to what operations you can do with some type of data. So we have data, and we're going to find its level of measurement. The kinds of things we might be interested in, can we do this or not, is can you order the data? Can you go from small to big, worst to best, those kinds of things. Can you subtract? I'm just going to turn it to be kind of like, can you take an average? And not just can you subtract the data, but does it make sense? So, if I subtract the numbers, does it have some sort of meaning? Is that a certain number or something? Also, can you divide? Talk about this later on. Could you say take 4 divided by 2 and give you a 2? And does that mean 2 is like twice of something? That's really the kinds of things we're looking at. So we're going to deal with levels. We're going to do sort of the most general level from the let's start with, and this is nominal level. So data at the nominal level just means you can sort of take the data and put it into categories. So nominal would be it has a name. So all we're going to do is put our data into sort of categories here. And if we're at the nominal level and we're not at the other levels we'll talk about in a bit, then it will sort of will have a name, but it won't make sense to order the data or subtract the data or divide the data. So some examples of this, you could look at hair color. So you could say we have people with black hair, blonde hair, red hair, gray hair, white hair. But you really wouldn't necessarily want to put those in a sort of obvious order. Now you could sort of make an argument that we go like light to dark, but then something like red, where's that fit in versus say brown? It's not quite clear what that order would be. So probably we'd want to say hair color is at a nominal level. You couldn't really subtract two hair colors. Like take a difference, you couldn't really divide them. There's no sort of numbers there. Now with a number, you can do a phone number. Now, okay, so you could take a bunch of phone numbers and order them from least to greatest, but it's not really indicative if my phone number is smaller than your phone number that means anything in any sort of order here. You could do ethnicity, so you could take somebody who's from one ethnic group, somebody from another ethnic group. You're not going to like subtract or order these in any kind of way. You could do type or maybe genre of music. So if you look at rap music versus country music versus blues versus rock versus classical, you can't really subtract, order, divide. This is really just a name. We're putting these into a category. So next level is going to be ordinal level. So everything at ordinal will really be at nominal as well. You can always throw a name in here. But now we're going to be able to order these and that order the data, and that order is going to make sense. So some examples here. You could do, say, number of stars in a review of a product on some website. So we could say 3-star versus 5-star. The 5-star rated thing is presumably a higher review or a better product. Here, note, if we're at ordinal and not at the next levels up, we'll be able to order, but we won't be able to say subtract. So we're going to say is that 5 minus 3, okay, you could 5 stars minus 3 stars, you could subtract and get 2 stars, but that's not really 2, okay, it's 2 stars, but it doesn't mean it's 2 better or something like that. Another example here at ordinal, not with numbers, you could sort of rate again with like categories like poor, mediocre, good, great, excellent. Here what we're going to say is, I mean, you can't really subtract. I guess you could do 1, 2, 3, 4, 5, but the difference between, say, good and excellent may be bigger or smaller than the difference between good and poor. So that difference of 2 isn't really consistent depending on which ones you're measuring. So really when I want to say subtract, you would say this is really an ordinal level. Names, I mean, you could argue that maybe this should be nominal, but sometimes you could sort things alphabetically and say someone's name comes before someone else's alphabetically, and that might have some meaning in some context. Again, you could kind of do this with phone numbers as well, but I think that's not nearly as typical a thing to do. Also point out that a lot of these levels of measurement, they're sort of gray areas. This isn't going to be a particularly precise sort of thing. We're saying, is there meaning to this? And you could maybe make some kind of argument here. We're just trying to get at a general sense of what's going on. Another ordinal type of thing is ranking of, say, sports teams. So say some basketball team is ranked 3rd versus some other basketball team ranked 12th. The team ranked 3rd is supposedly better than the team ranked 12th here. Also, you wouldn't want to subtract because sort of the difference in quality between the team ranked 3rd and the team ranked 12th, I guess, is 9 rankings. But that might be a much different difference than between the team ranked, say, 16th and 25th. One of those gaps may be sort of a much bigger difference in quality than the others. It's sort of that 9 doesn't necessarily mean anything intrinsically. Next level up, where sort of our differences do have intrinsic meaning, this is interval level. So this is when I'm at the interval level, we can subtract data in a way where the difference has some kind of intrinsic meaning. Now what that's going to mean really is, in some sense, we can average, we can take 2 data values and find exactly what's in the middle, because that point is sort of the same difference from both of the 2 endpoints. Same distance from the 2 endpoints, but that's distances from a difference. Okay, some examples of interval level. So you could do temperature. So I could say as it's 18 degrees as a high today, and it's 35 degrees as a high tomorrow. Tomorrow's high is 17 degrees warmer, and that 17 degrees sort of means something intrinsically where it's 17 degrees warmer. It's in some sense the difference between 60 and 77, 60 degrees and 77 degrees also is 17 degrees. And there's some sense, and this is maybe a little bit vague, where that 17 degrees between 60 and 77 is in some sense the same as the 17 degree difference between 18 degrees and 35 degrees. So temperature generally we would think of as an interval level. You can subtract temperatures, or probably a better way to think about this is you could average temperatures. Time of day would be another thing you could do, where you could say, now this one, the difference really makes more sense here than probably the average, that if I go and I exercise from 9 to 9:30, that's 30 minutes. If I go and exercise from 12:15 to 12:45, that's also 30 minutes. And the 30 minutes is sort of the same in each situation. Year would be another idea of you could do interval. And so you could do a year of 1920 versus 1950. Those are 30 years apart. Same thing as between 1980 and 2010, also 30 years apart. And just a little note here, kind of mentioned this already, is that really if we have data at the interval level, it's also going to be at the ordinal level and at the nominal level. And so generally what we're going to do is be able to treat data in certain ways, where we can do this if data is at the interval level, or some other thing if data is at the ordinal level. But if you have interval level data, you can do the thing to it at ordinal level, because interval level data is also ordinal. So these levels kind of get more and more specific as we go up. Last one we're going to talk about is the ratio level. And ratio level is we can divide 2 sort of data quantities in a way where the quotient has some sort of intrinsic meaning. Probably an easier way to think about this, in some sense perhaps equivalent, is that the 0 actually means you get nothing of something. So it means sort of the absence, the lack of something. So some examples here. If we do height of a person in inches, you could say that someone is twice as tall as someone else. Here, so if someone was 30 inches tall and somebody else was 60 inches tall, you could say the person who's 60 inches tall is 60 divided by 3 is 2. So the 60-inch tall person is twice as tall as a 30-inch tall person. So probably talking maybe an adult and some kind of child here. Also, 0 inches. Now, we're not going to have people that are 0 inches tall, but if you somehow theoretically did, you'd say, oh, that's sort of the absence of height. So that 0 means nothing in some sense. And you could measure certain things like, I don't know, maybe how much pencil you have left on a pencil where you're sharpening off parts of it as you go, and you might say, oh, it's down to nothing. That 0 might actually mean 0 here, might be attainable. Another example would be the time you spend exercising. So I might spend 20 minutes exercising, somebody else spends 60 minutes exercising. 60 divided by 20 would be 3. So that means they spent 3 times as much time exercising as me. So that quotient has some kind of meaning. Could also view this as 0 minutes spent exercising means I did not exercise at all, sort of a lack of something or an absence. Another example is number of siblings. So if I have 4 siblings and somebody else has 1 sibling, you could say I have 4 times as many siblings as that other person. Or you view this as from the 0 point of view. So having no siblings, I guess, means you're an only child here, but means there's nothing. You have none, no, sort of 0 has some sort of intrinsic meaning of nothing. Okay, and again, if you're at the ratio level, then you're also at the interval level, also at the ordinal level. This may not be completely obvious here, where if you can do this quotients, you should be able to subtract as well. It's going to at least be true for all the types of data we're going to be concerned with in this course. Okay, so last slide here, we're going to do some examples here and talk about what level of measurement we're going to get. So if we do age of a person, now what's going to happen with each of these? I sort of sorted these from nominal, ordinal, interval, ratio. It's getting sort of more specific as we go. Sometimes I guess it's an ordinal level. Or if we put an x here to say, oh, this is nominal, and an x here to say this is ordinal, sort of we'll go along. If you end up with an x at, say, ratio, it means you have to have an x in the 3 boxes to the left. If you ended up with an x at interval, you'd have to get the 2 to the left and so on. So new age of a person. Now, everything's going to be nominal. So I could take people here and sort everyone by people who are 12 years old, people who are 87 years old. Just take how old you are and have you sort of be the category you belong to. So age of person is is nominal. Ordinal means we can say one person is older than another. So you've lived sort of number of years old you are is bigger, means you're sort of older. There's some sort of sense to putting these in order. So this would be ordinal. Interval would be to say someone is, you have a 12-year-old and a 7-year-old. 12 minus 7 is 5. That 5 years sort of has some intrinsic meaning of being 5 different. Here. So age would be interval. Ratio we could do as well here. And the idea here, depending on how you want to look at it, is someone who's 8 years old is twice as old as someone who's 4 years old. So 8 divided by 4 would give you the 2. Or you could say 0 years old would be a newborn, but it's sort of lack of age in some sense. So that 0 means you're missing age or it's absence of. Okay, so that's age of a person. We can contrast that with year of birth here in the next row. So again, this is going to be nominal. People born in 1958, people born in 2007, and so on. So everything in this chart is going to be nominal. Basically, any data you have at all can be nominal. Ordinal means you can order sort of year of birth, and that has some intrinsic meaning, like how old you are would be tied up with that. So year of birth is going to be ordinal. Interval means we can subtract. So if you had somebody born in 1946, somebody born in 1949, I don't really need to even figure out how old these people are, but I could do 1949 minus 1946. That could be a difference of 3. That means the person born in 1946 is 3 years older than the person born in 1949, and that 3, it's like 3 years, it has some meaning. So year of birth would be interval. Year of birth, however, is not going to be ratio. So if something or someone was born in the year 2000, someone who's twice as old as them, or would be, I guess, born in the year 1000, half of that, or maybe you'd say 4000, doesn't really make sense to be twice as old if we're looking at the year. Another way you could view this is the year 0 doesn't really mean like sort of the absence of time or something. I mean, there's certain religious significance to this, but it's not really absence or sort of from a quantitative point of view, at least. Okay, next one, income. It's certainly going to be nominal, so let's say the number of dollars you earn in a year. You could also do ordinal here. You could sort of sort people by how much money they make in a year from sort of the least amount of money to the greatest, or vice versa. Income could also be interval. It makes sense to say I made $10,000 more than you. You could also do ratio, where if someone makes $20,000 in a year, that's twice as much as someone making $10,000 in a year. Also, you could view this as if you make $0, that means you sort of did not earn anything. That 0 has meaning of nothing. Next one, temperature in this room. So again, this could be nominal. You could have a room that's temperature 65 degrees, a room that's temperature 82 degrees, and so on. So everything is going to be nominal. Ordinal, the higher the temperature is, sort of the hotter the room would be, and so sort of this makes sense to order temperature, order rooms by the temperature in the room. So you can take those numbers and order them. You could also do interval. So the interval here would be one room is kept at 75 degrees, room B is, say, kept at 70 degrees. That's a 5-degree difference, and that 5 degrees sort of means something. Ratio is not going to work for temperature. So if you're in a room, a couple ways to think about this, where if you have room A is 80 degrees, room B is 40 degrees, we wouldn't really want to say that room A is twice as warm as room B. Also, 0 degrees can be cold, but it's not like all the temperature is gone. I mean, you can kind of go negative here, perhaps would be another way to look at that, where it's just sort of -1 to 0 to 1, all the same step size here. So temperature is not ratio. There's sort of an exception here, where if you measure things in Kelvin and you deal with absolute value, or absolute zero, so absolute zero would be sort of when all particles and some molecules stop moving. So this is some sort of more specific chemistry concept. So absolute zero, you could view temperatures in a ratio level if you did everything in Kelvin or some scale that was 0 at absolute zero. So you could say that somehow twice as warm really meant, or twice as high a temperature meant sort of twice as much motion or something like that in terms of the Kelvin scale here. But it's not normally what we're talking about. Next one, we do rankings of a basketball team. This is certainly nominal here. So you could have all the teams ranked second, all the teams ranked 8th, all the teams ranked 12th, and so on. You could do ordinal. Team ranked 3rd should be better than a team ranked 22nd. Interval. Now, this gets a little bit tricky. So I'd say this is not interval. So the next one we've got is nominal in the next line. So I would say ratings of a basketball team is not interval. And what we want to think about is, well, if one team is ranked 3rd and another is ranked 5th, that's a difference of 2 rankings. But then if you had a team ranked 19th and a team ranked 21st, that's also a difference of 2. But sort of the quality difference may actually be more significant. Probably the team's lower rankings, that spots probably mean a little bit more once you get higher rankings, 19 to 21. Teams are probably more or less about equivalent anyway. Yeah. Might be the case higher, but maybe not. Okay, next one, state of residence. So if we're in a state, I mean, you can list states by name. Probably wouldn't want to do ordinal. So there's no sort of obvious order to put on states. Should Utah come before Georgia or before New Jersey? How do you put those in order? I mean, that's not to say you couldn't do that in terms of land area of the state, population of the state, what year the state was introduced became a state, I guess. So there's certain orders you can put on here, maybe alphabetical, but there's no sort of inherent sort of obvious natural order here. Again, this can be a little bit of a gray area. We may have to explain your answers if you're not sure of how things are going. So I would just say state of residence is nominal and not ordinal, not interval, not ratio. Now, population of a city, okay, this could be nominal. We could sort of put a city in the category of all cities with population 12,432. Kind of a strange thing to do, but you could do that. I would say population of a city is ordinal. You could list cities from smallest to biggest in terms of population. You could do interval for population as well. You could say one city has 20,000 more people than another. And you could do ratio as well here. That would be a city of population 50,000 is twice as big as a city of population 25,000. Or population of 0 means no people, sort of the absence of people. Okay, last two deal with time. Sort of interesting because you can definitely convert back and forth between these. But the first one I'm going to do is say time entering a classroom. So suppose you've got a class that starts at noon. When we talk about time entered the classroom, you could list out all of the students in the class by students who entered the classroom at 11:50, and then students entered at 11:51, and so on. You could do categories by time, or maybe ranges of time if you're going to go by seconds or something more fine than just minutes. You could do ordinal. You could say that if Student A entered the classroom at 11:50. Student B entered the classroom at 11:56. Student B entered the classroom later than student A. So sort of those numbers, sort of the ordering on the numbers is some sort of real intrinsic ordering on what's going on. You could do interval here. So someone who entered the room at 11:51 versus someone who entered the room at 11:54, you have a 3-minute difference. And that means the one student entered the room 3 minutes earlier or perhaps 3 minutes later than the other student. Now, ratio is not going to work here. So the idea here is that, I can't really divide. I wouldn't want to say that a student entered the room at 11:56 divided by 11:50, even if I sort of converted those hours to minutes, it wouldn't really work. The other thing is there's no real zero here. So it's 0 hours, I guess maybe that's midnight, but it's not like the absence of time. It's sort of just a sort of arbitrary point here. So when we're talking about time here, I would say this is nominal ordinal interval. So interval is like the most specific level we have, but not ratio. Now, you could convert this equivalently to the number of minutes early to class. So if class started at noon and you showed up at 11:50, you were 10 minutes early. So that would certainly be nominal. You could take all the students who were 9 minutes early, 6 minutes early, 3 minutes early, categorize students by how many minutes early they were. You could do ordinal if a student sort of was to class 5 minutes early versus 3 minutes early. The student who was 5 minutes early was in the classroom before the student who was 3 minutes early. So sort of the ordering of the numbers is the same thing as some sort of intrinsic ordering. You could do interval if student A showed up 4 minutes early, student B showed up 1 minute early, 4 minus 1 is 3. That 3 minutes has 4 minus 1 is 3, has some sort of intrinsic meaning in terms of minutes earlier. And in this case, you could also do ratio. So you could do 0, meaning really at the start of class here. So you could say, particularly if we're only talking about positive numbers, assuming everyone shows up at least on time, that a student who showed up 4 minutes early versus a student who showed up 2 minutes early, one of those students showed up twice as many minutes early. Now, I don't know that you'd want to say twice as early, but you could say twice as many minutes, and that sort of doubling has a certain amount of sense here. So I would say this is ratio level of measurement.